Hello, everyone. Good morning, good evening, good afternoon from everywhere you are. This is Mohsen from Microsoft Zero to Hero. After I think 3 or 4 months, I'm back with another session with on hosted in the Microsoft Zero to Hero. I hope you have a great day. Today we have a great session about the data platform on the Azure. Before to invite our speaker to the stage, let me share some slide about the community. Today we have Kumuda. She wants to talk about that data platform on the Azure. She has, before the session started in the backstage, I talked with Kumuda. She's expert in the data platform, and the topic is very interesting. I think you enjoyed this session. As you know, we are part of Microsoft Learn community. Microsoft Learn community is uh, the set of collaboration, the learning content. You can, based off your career, based off the certificate, based off your role, you can find the learn content, and you can ask your question from the learn expert, and you collaborate with the other people and other students, and you can improve your career path and knowledge. And the last slide is our code of conduct. Be aware of others, be friendly and passionate, be welcoming and respectful, and be open to all questions and viewpoints in the chat, your question. And the time is at Commander in the stage. Hello again. How are you?
Hello, I'm good. Hello, everyone.
Just before you start your session, as you know, that the last month it was the MVP summit, and there are a lot of new things that Microsoft published. Is there any news from data platform or like that? Do you have any news?
Not really. It's been by quite a bit down, but we have heard that there's a lot of Azure, which is collaborating with AI right now. So, especially they changed the permissions 3 weeks back, and we all know that. I think that's the biggest news right now. Yep.
Oh, cool. Yeah, cool. Just before you start your session, for audience, you can ask your question in the comment. End of the session, Komodo will answer your question. Let me add your presentation on the stage. Yeah, we have your presentation, and you can start.
Hello, everyone. So, thank you for being here. So, today I'll be talking about designing autonomous self-healing data platform on Azure. So, I have 6 years of experience working as a data architect, and one of the things we always think about is like any data platform, or if we're working with any SQL or something, right? So, first question is like it's have a human loop all the time. So we'll be talking a very interesting topic today, which is being autonomous. Autonomous is like you take action without having a human in loop. So that's for at least like you have has a data architect or a data platform developer. You always look for the failure patterns, but has not a human like in the loop. How we're gonna do it with the self healing, which is like it doesn't detect problems; it also fixes them. So at the end of this whole section, you will learn about more into architecture. I'll go through some codes and also governance model, and especially the what are the security you need to follow. And also I'm going to go through like a 12-week roadmap where you can learn a lot of things like yourself, so that it's step aside for the whole things. So the whole section I have made it into like the problems, the definition. I'll go through like 1 to 5 slides, and we will go into like deep into the reference architecture, each layer and service. Then we will be moving on to like have few codes like which I have taken a screenshot and coded. So which is on like Spark and Logic apps. Then we'll go through some of the architecture end-to-end system, like how you have to design from the first system layer to the end. Then we'll go through some governance rules, observability, and some patterns. And from 29 to 35 slides, we'll go through how do you can design patterns, and what's the maturity model and the ROI. And 36 to 40 will just more into focus on like, as a person on your own who wants to learn more into this, what's the next roadmap, what's the next road step. So let's begin with the whole pain, right? So there are, you see all this like numbers literally, but you are like thinking like, is that theoretical? Is that the real numbers? But these are the real industry benchmarks if you really see. When you see about this 500K, right? That's the number of hours. That's the average cost to, let's say you're having a pipeline outage. That's the average cost which causes them. It's not the engineer time. It's like you're delaying the business decisions. Like there's incorrect reports going to executives levels, there's SLA penalties, and there's a lot of customer impact. And most of them is due to like, as a working in a team, we have like 73% reported failures every week, like literally. So we are, most of the failures are like, they are dealt by data engineering team. So if something is breaking every week, it's not your team alone. You are also like, you have to be in a place in a team with the whole thing, not a good place. And average time for a recovery is estimated to be around like 4.2 hours. Just that, like the whole half a day is just lost to a single incident. So let's dig in more, like why do pipelines break? When you're in a data team, you always think like, what's really happening out there? So there's three types, I mean three modes or three reasons like the whole pipeline breaks. Let's take schema drift. That's the first one. uh, let's say a SaaS vendor, a API, suddenly renames its data type. Like you're having like, let's say customer ID, which is like an integer. So it suddenly takes up like arise as like you have a results which is taken as a string. So from customer underscore ID, it's renamed to customer ID. But all the everything, the flags doesn't break. It's like your pipeline breaks. That's one of the first mode. There's another mode called as upstream API changes. You have the, I mean, you would have designed everything. So you have the REST API points, right? So that API points, it's like its version is versioned out. So a third party vendor, let's say, has like a endpoint with 30-day notice buried along, like no one, I mean, has a data team or someone you can't really read. But your pipeline suddenly goes into 404 or a malformed like response. So that's like upstream API change. That's the second reason. If we really go about like instability, infrastructure instability, like I think most of us have faced that. Like, for example, Spark workers suddenly run out of memory. Network, like timeout due to storage run out of memory is the biggest problem. So that's one thing. And they're very hard to diagnose, because just say like executor is lost it. So how do you go and see like if the memory has run out of, like it's run out of memory, or there is like a timeout or something. Under all of this human error, like we have, for me example, when I first joined, I deployed it in a wrong environment, and there was like some mistakes like ad hoc changes. So that's all like included. Like human error is would be the last mode, but we do errors. So this is the fragility problem which we are facing as a data engineer or a pipeline which you do. So most, if you're running a most mode dashboard or a rotation, this would not solve a problem. A person who is sitting on a desk as a data engineer have to dig in more. So this is like you're not doing your job or has like a developer, but you're just fixing errors. So how do we have a structural solution? That's what we are going to cover today. So, what does self healing means? So, I already told, right? Like, self healing means without a human in loop. So, first thing for any person or any machine or anything, right? So, first thing is detect. So, how do we detect without a human in loop? So, if you're sending like a continuous telemetry or anomaly signal surface within like 60 to 90 seconds, then the stakeholder or a person can say, hey, there's something wrong with, for example, if you're using a data stream, you have like an integer suddenly turns into string. So detection is more important. Like every you can send like a alert mail within 90 seconds, automated detection automation. That is one of the first step you have to do. So when the alert is fired, what should your AI should do? Your AI agent should read the error context, like, hey, what's went wrong? What's the data lineage? Like, what was the recent pipeline run history? Like, what was the strings you wanted to see, or something like that, and diagnose like the root problem. You should not say just say like, hey, pipeline failed, but where did it fail, right? So let's say that there's orders silver table or something, and amount changed from integer to like float in a third layer or something. So it should say like, hey, three downstreams dbt models kind of affected, and what's the confidence level? That's like 92%, and what would be the recommended action you have to take? So it would say like, take a schema evaluation run book or something, and you have detected the problem, you have diagnosed the problem, and maybe have recommended some of the actions. But what if for the known failure patterns, your AI knows how to repair itself without waiting for a human? Let's say you're at 2 a.m. or something, you can't wait for a human to, and it really knows that failure patterns. It should evolve schema, it should reroute, like, oh, this pipeline is broken, it can reroute to in another pipeline. And it should quarantine the bad records, like for example, what you had like integers instead, sorry, in strings instead of integer. It should like take out the bad records and quarantine it, and roll back to the latest good snapshot back to this old pipeline. And it should be all policy driven. That's how like the whole self healing actually means. And for all of this, if you're like really talking about self healing, there should be zero human intervention. So coming to the next one, we talk about like what is really like the four pillars of autonomous data platform. We talked about autonomous self healing, but what about autonomous data platform? So we have four pillars, which is the prerequisite of the whole thing. First is observability. We have to be like simple thing. You cannot heal what you see, right? So you have to talk about data lineage, pipeline metry, anomaly signals. So if you don't know a data set exists, if you don't know what depends on it, so there's no telemetry with whatever it's fresh, so you're flying blind to a particular thing. So observability is not like a feature you can add later, it is the foundation. So you need to kind of like see what is the pipeline, what is the signals, like every 30 second 90 second it's sending, and you have to observe the whole thing. And declarative orchestration. So there are few pipelines which is like intent based. Instead of writing like how your data moves, what you declare, and what your outcome becomes, you can have the platform resolves the how. This is like, how do you make the pipeline resilient? How should our infrastructure change? How the declarative layer should adapt without like rewriting your whole logic. Instead of writing like how your data is changing, what is your outcome, you should not touch that, but you have to make sure that whatever infrastructure you're giving to the pipeline, you can change that, but with you should not touch your logic. That's one of the declarative orchestration, always keep in mind. And policy driven governance. So you should have always have rules, right? Even in a school, if you're standing in a line, you should have rules like, hey, stand in a line by the order of height or something, so that you don't have a system which quarantines suddenly from like even a good record or something. So auto quarantine rules, that's the most things. And you should have a quality rules, like whatever the embedded code in your pipeline metadata, you should not check manually like each every time. It should be executed as a policy. Just like when a pipeline is executed, your policy should be executed. And closed loop automation, that's like one of the, like every AI agent or every AI assistant remediation agent, I would say, should have that complete loop. So when the first three, observability, declarativity, and policy, are like right in a place, this kind of makes a closed loop. And fourth is like you have managing a platform into an autonomous one. So like if you want to give like let me give you an example of a car, right? So observability is your like you're observing your dashboard, declarative is your cruise control basically, and policy driven is like when you're changing your lanes, and closed loop automation is fully self-driving. You all need all four of that. So that's a good example if you really want to know about autonomous data platform. So when we are talking about Azure service landscape, so we have like 9 services, right? So everyone would have heard about Microsoft Fabric. Our first, like that's our unified analytical platform. And OneLake will act as our storage layer. Spark is the compute engine, and DBT and notebooks will run into like run inside the Fabric. So all of this will talk to OneLake, which simplifies the whole data estate enormously. When we come to Azure Data Factory, it manages our ETL, ELT, and whatever. When I talked about schema drift, it has like a built-in detection for that. And Azure Data Platform, even like if there's a small like schema drift, it just handles itself than like showing a failure or something. And when we come to Azure Event Hubs, it's like high throughput scheming. Like basically, it comes with a schema registry. For example, you have a producer register, and they have all your schema there. It actually validates each every message at a published time. So Azure Event Hubs is one of the best example for that. And Microsoft Purview is like governance, auto discover data sets. If you're talking about policy, you can use the Microsoft Purview, and it captures like end to end basically and enforces the data policies. So if you're talking about governance or policies, you should always talk about Microsoft Purview. Azure Monitor, if we are talking about uh, like the whole data platform self-healing. So how do you do that, right? You need a signal which is saying like what are the metrics, how is your whole pipeline running, how what are the test results, like is it going like going from one workspace to another, is there like if it's writing a SQL query, is it like on the alert condition? Azure Monitor takes care of it. And you do need an AI brain. So I have opted for this whole thing is Azure OpenAI services as the GPT 4o. So it is actually pretty good with like alert fires and the context and classifying the root cause. It is one of the best, I would say, like for the whole Azure, or like if you're talking about any data pipeline or something. And we have logic apps, which is like everything is data event driven, I would say. So if you have a logic app is the glue. It like monitors the alert, it gets all the context, and it calls the OpenAI, and it basically runs the runbook. And Azure automation, it is like triggering like if you have schemas, you need to re-trigger, right? Like basically you had a AI agent, you Azure logic apps call the AI agent, it gave the context, but who runs it, right? So that's Azure automation. So it runs the PowerShell or a Python that like, kind of evokes the schemas. If there is any process which is like failed or something, it re-triggers it. So that's what Azure automation does. And we have Delta One Lake, which is our everything's happening, but you need a storage format. So for example, you have a schema, what developed, you need to store it somewhere. That's where Delta Lake or One Lake is where you store. So the whole thing is like I talked about so many stuff, but what do you need, right? That's the architecture. So how can we architecturally see the services, right? So there's 4 layers. Let's go from top to bottom. So ingest layer, like you get the streaming data. It is done into batches, and each there's a schema which is registry, which like validates each messages on publish, and you have got like a queue basically in the ingest layer, So you get the data, you get like making into batch ingestions, you get your schema on place and get your queue. So the next layer is like, yep, you have got the data. What you're going to do? You're going to process it. So Spark on for Fabric basically transform the data, and DBT contracts enforce like, hey, is there a quality on the at the silver layer? But you have done like, hey, you have transformed the data, but where do you store it? So that's where the like one leg comes. It provides storage with ACID guarantee, and that's all done. Like, hey, everything is done, you have checked the quality, you have stored everything. What about the failed records? What about the remediations? You need to quarantine it. So that's where quarantine tables come hold. Like, let's say like some of the records have integer or something, you want to hold it, quarantine table holds the failed record for you. And so everything is ready. So you want to put it down to a dashboard, let's say. So that's where the server layer comes. So you have like a Power BI web for dashboard, or you can use this data right now for our doc queries in SQL. And if you have a REST API, you can just use it for your operational consumers or a consumer side, basically. That's the whole part of like, you ingest the data, you process it, basically take out the bad records, you quarantine it, you put it into the dashboard or like a SQL for your ad hoc query. This is like the whole high level reference architecture. So when it comes to like, I was talking about so many tools, right? So how do I take the control plane? So you need a like a nervous system basically watching over the whole entire platform. If something goes wrong in this three, like ingest, progress or serve, right, you need to detect it and basically act upon it. So you start with Azure Monitor, and you have like the logic apps. You have the AI chat GPT, which is like, seeing like what's the context, what's the data it is taking in. And you have like the Azure automation runbooks, which is calling the chat GPT API. And you have the alerts or like, the policies done by the Microsoft Purview. So Azure logic apps, you're checking your logic, then you're calling the chat GPT if there's a failure or you want to re-trigger everything, done by the Azure automation runbooks. Then you're going to the policies or anything by Purview. So I talked about like a lot of things, basically like how do you ingest and everything. But in depth, when I go, this is where like when you're getting a flow of data, that's where like most of the failure happens. So I have like four things which make sure there is like a good ingestion of data, rather than like no schema or something like which is pulling wrong things. So we have something called as Azure Event Hubs, which I talked about earlier, and also schema registry. So what does it that do is, it before upfront only, it produces register schema upfront. So every message is validated at a point. Like for example, you have like schema policies, like let's say forward, full, or anything. So when the data is coming from the source, any bad data or like which has a bad schema or something, it doesn't enter. It's data is caught at the source itself rather than the destination. That's what's like event hubs or schema registry do. If you publish like the policies of the schema and upfront, like before the data even comes, and when if something goes wrong, you take out the bad data and before it hits the basically the pipeline. And second one is the ADF mapping data flows. I already talked about schema drift detection, right? From integer, sorry, uh, integer to string. So how do you detect it, right? So we have like, for data that arrives at the ADF mapping data flows, you have already published that, hey, this is for example, let's say XYZ column, which is only accepting integer. If there is any change columns, which is a string or anything, that change columns are automatically captured. And rather than causing a failure in the whole pipeline, it captures at the start and just says like, hey, this is auto detected, so remove that good rows, and it goes into quarantine. So so that the whole downstream is not like kind of blocked or anything. So that's how you get the ADF mapping data flows. And we have something called as dead letter queue pattern. So for example, let's say failed record, have like a, you're in a quarantine like that failed record, but we have in the one lake a dedicated storage for them, because you may use it, you may have like something which you can pre-process it or those records, so you don't want to disregard it. So when the root cause, let's say you're expecting integers and you got a string, and when that whole thing is fixed, you can get this record, get it fixed, and just re-merge it and run safely. So there's no duplicates of like integers or something like which is the whole thing is going wrong. So that's how you get the bad records into a quarantine, fix the problem, get the root cause done, and take that data and merge it and run the whole pipeline. And every new data set, right, it triggers a purview scan. So for example, let's say you're ingesting a lineage or something, you already have like a violations on the surface. So if you have caught all of the things, you just like say it went down, let's say it needs to be integer, it needs to be 325 characteristics, and it needs to trigger like, hey, this data stream is lost, is there a duplicate or something, that auto scans the whole thing. So you have the architecture which is making sure you get the good, I would say, good record of data stream. That's the whole like schema aware streaming which I talked right now. Here this is where you have the data, but you need to kind of like talk about processing the whole thing. So we have three layers, which I call it as brown, silver, gold, like three medallions who have won a race, just standing there like I got a bronze, silver, and gold. So when it comes to bronze, so this is a raw. We have like the historical record, like as soon as it arrives, we have the version. Let's say we have like 12 data streams coming in a pipeline, and few of the bad data records went off to quarantine. That is the version 2. It was fixed, it came into rerun. That was version 3. So you have all the versions of the data. So it's just like an audit log, like from where it arrived, what happened, everything. So it's just a bronze raw, like it just have like a schema on read, like what happened to the data, can you go to that previous version or something. Now it comes as silver, which is like where the quality is enforced, like it's like DBT model. So if let's say a record fails on a quality model, let's say you have a null primary key or a negative dollar amount, or you have like a invalid status code or something, then it says like, hey, you have like kind of primary key and it is a null, which is not we were expecting. So just quarantine. So it is not dropped, but it's just in a quarantine table. So it is cleaning up all the like invalid status code or a negative dollar value. It is just quarantined with the, it is tagged with a reason, like a failure reason. Then comes the gold, which is the business ready. You already have the SLA guarantee table, all the bad records have been taken out. So this data is ready to be connected to any dashboard or like a Power BI, or you can use it for your query, or like you have like a manager who can trust like, hey, this data is clean. That's where the goal comes for. uh, yes. So we talked about how do we ingest the data, how do we make it kind of like data ready, and where we can connect it to the dashboards directly. That's where we talk about the whole thing. So we're going to talk about like autonomous orchestration, like how do we have the heart of the whole architecture, where we like fire alert or something. So when you talk about having architecture, you first thing is like, for example, you have a fire alarm, you always have an alert. So you talk about like, hey, there's a pipeline failure, there's a schema validation error. So that's the first is the signal. So then okay, you had like, okay, fire alarm, what is the context, what did it happen, right? So that's the context. Like logical apps usually don't invoke a run books suddenly without a context. So what it first fetches is the pipeline error via http. Then it queries like, hey, what was the dependencies, what was the downstream, what was caused it to impact. So that's the context. Then you diagnose like, hey, what happened, I have the context, I have the alert, what was it caused by. Then you send it to your Azure OpenAI GPT-4.0 to act as like, see, read all of these things, read the logs, read the deltas, and like return a JSON object with like, what was your confidence score, and what's the real root cause of the classification, and can I run the run book to invoke, and is it not, like, kind of not really I can't do it, or something like AI says, I really can't do this, escalate this to a human or something. So that's where diagnosis happen. And remediate, like, let's say it was a very small problem, logic apps just takes a runbook name, OpenAI responses and invokes the Azure automation, and it quarantines whatever is there, or you have to go to a previous version. It does that, and within under, let's say it is not done like it's under 5 minutes. It's there's zero human intervention. So this is the best method. But the whole thing is like, if it is really really bad, we do escalate to humans. So this loop runs every 24 into 7. So let's go to the next code walkthroughs. So if you're looking at this is like the ADF mapping data pipeline. If you see a low scheme drift, right? This is the most important thing. So it expects the source schema to match exactly what was in the data set. If, let's say, if a person adds a new column or a, renames a new one, the whole pipeline fails. So with allow schema drift true, it captures or any, like, whatever you have changed from new or any change column names without failing. It adapts to the schema automatically. Let's say you had done before the pipeline goes on, and you did not trigger or anything. It just like adjusts itself. Hey, you changed the name, so I'm just going to change the names in the expected data flow, and I'm just going to adapt automatically. And there's something called validate schema, which is false. Like whatever hand in hand schema which is happening, it just like not rigidly enforce the data. We are going to, like, first think about what's the dbt layers, is there any expressions which is went wrong or anything. So validate the schema, it's not like rigidly enforcing it but validating it. And we have something called dead letter linked services. So it's, if you have heard about GDLS Gen 2 container, which separates the bad records from the partition path. Like, let's say you change the column names, but still the record is bad. It just puts into a quarantine. You can see that dead letter path, which is quarantine browns, run ID and date. So it's giving you a date timestamp so that you can know like what went wrong, what was the bad record, and everything. And let's say like the bad record you had was like, you detected the cause and you want to rewrite it back into the pipeline. So that's where it is write behavior upward, which writes back to the one lake, and your pipeline is ready to, kind of rerun, and it's not going to crash any halfway through. And also, like, it's gonna say like, hey, have a bad record, but it's also a duplicate record is also there. So it avoids that basically right behavior. That's the whole thing of this, the scheme of that. So when we come to code event hubs schema registry, that's where we like kind of import the schema registry. There's like two of them, which is the schema registry client, and one is the Avro code. So it looks up at the main schema using schema ID. If you really see, there's a schema ID, and it validates the order. Like, hey, this is the directory. Whoa, like what's really happening? Let's say in a normal pipeline, right? You discover some problem at the consumer side at 4 o'clock, or like there's where like a lot of, let's say, like 10,000 million records, which has already been ingested incorrectly. And you want to discover like what is like the schema problem at the real time, like each and every is this schema correct, is this feedback loop in like correct. You can't do it like, you can't take sit down and take like 4 hours or 5 hours just to look at those 10,000 records. You need to have it in real time, and the feedback loop in seconds. That's where this event hub schema registry comes, and it takes up the schema id. You have a registry where it expects like, let's say, like the client order group and everything. It goes through each and every record and says that, hey, this is correct, this is not correct. So it basically validates against the order. That's what the event hub does. We have one lake. This is where that moves the data from bronze to silver, like whatever the bad records you had went through, whatever the schema records you have went through, you have taken it out, and you have the ready data to be ingested by the basically by any Power BI dashboard or SQL. That's where you change from like, you're reading the whole format and you are noticing like, hey, the schema may have drifted or something. Like, for example, you have something called spark read dot format delta dot load bronze path. So if we had drifted from the schema, that's where it was loaded and fixed. Now it has gracefully, like, kind of validated, and it's ready to go back to the silver, like basically the silver path, which has the delta table dot for path for silver path. That gives you like whatever the bad records were there, it has been corrected. It's sitting there waiting for you to get fetched. So we combine the bronze record with the silver record and then update whatever had matched up, remove the duplicate based on the order ID. Then we merge it and we execute the whole transaction. That's the whole code, what it's doing. It takes the data of the first, where it took out like some invalid columns or anything. Second one was the bronze, was you validated against the schema. Now you combine both of it together, remove any duplicates, or see the policy is going through and make it a golden standard data. Now coming to DBT model contract. So you have the whole thing done, but you need to have the two silver and bronze to be working to go good. But you need to also enforce that all the column names and the data type, whatever was in the bronze, is matching with the silver. So that's what contract.enforce.true is checking. And you want to check for any null constraint, like I already talked about null primary value or anything. So you're checking called as constraints underscore not null any of the column name, which is like, for example, in mine it's order id or the customer id. So it goes through that, hey, this order id and customer id is not null. So you're good with the SQL quarantine logic. So you can push out this whole columns or anything. So everything is done. You have merged everything. The policy is done. You checked if there's any null, but you need to see the whole, kind of updation. What did you monitor, right? So it does take like, hey, every 2 hours I have been like, checking this, and after 4 hour there was like something went wrong, I corrected it. So that's where the SLA logic app, all this, the trigger works. So you have like the freshness one after 2 hours, error after 4 hours. So it gives you a alert at 2 hours if there is like, you have not done anything, or like any, the rule has not changed. It gives you an error after 4 hours. That's what the whole thing does. So how do you, everything is done, but what if there's a duplicate value, right? So you need to run a test. So that's where like test unique order ID. So you're making sure that every row in the column order ID is unique. So that's where you're running this test. So let's go to, so we talked about the whole, or duplicates, merging the whole thing. So So you have got a alert and everything. So let's say you have like you're monitoring something, and it fires like, hey, this is not a rule which is, it is breached basically. So where do I get the context, right? So in this you have the API logic system, which I'm going to talk about. So when monitor alerts a fire, type API connections. So what I'm talking about is like you have a logic app which is connected via action group or something. There's some alert rule which is breached. So you give a context which is like what the resources is failed and what did the query basically return. And the first action you would do is like get the pipeline logs. What happened, like let's say you are querying against huge logs, but you query only the relevant logs from the log side. You evaluate like, hey, what did you like, was it the upstream or a downstream, like what was the failing data set. You need, I mean, you have a AI, you need to give like a proper data to the AI. That's what this whole monitor alert to remediation does. So you need a monitoring system to be kind of attached, right? So you first get a trigger and you query against only the logs which you feel like which is a failure. You get the context, and let's say you have the failing data set, you got it. You need to get that dating failing data set, and you call the OpenAI diagnose, which is called has the call OpenAI diagnose. And then you assemble all the logs, the data, the context, and you give it to OpenAI. It diagnoses whatever it is there, and it classifies like 0 to 100, what's the confidence level. Let's say it's 78%. It classifies, hey, I can fix this. It invokes a run book basically, and it directly comes from the OpenAI response, decides like, hey, I want to, let's say like, I want to call like, I want to keep a new add new run book to automation, and all the other things is done by the chat GPT 4.0. So you're not touching your logic, like you're expecting a integer with the 356 character 6. You're not touching that. You're just changing the column name or the column type which you have expected based on the logic. So coming to the open AI diagnostic agent, we talked about the monitor, the ingestion of data, but the real vein is the code Azure Open AI diagnostic agent. So what does it do? So it expects three inputs basically. I already talked. It expects is the pipeline logs. What happened, like kind of like what was the error output, what was the execution trace. That's what it expects is the pipeline log. And for example, schema delta, like what fields went wrong, what's column names change. That's a schema delta, like before and after. That's what it requires. And was it in like the upstream or the downstream, like it's kind of expects the graph, like so the consumers, like, oh, it halfway went to the downstream or something. So everything you have, but let's say you're opening a chat GPT, right? So you gave like a big story and expected it to do something. You need to have like a very good prompt to get what you want. So this whole brain is engineered to give a specific role. Like for example, it will act as a data platform engineer, and you give the specific inputs. It it is assigned to basically act like, hey, the model is like, this is are the failure modes, you need to act upon this basically. So it does that and gives you the whole response in a JSON modes. Okay. Yeah, so you get the root cause, the confidence level, you have the run book. Do you want me to escalate it? That's what the whole open AI agent works. For example, let's say you have like a confidence of 0.55. It will say escalate with a human. We have done our best analysis. So, and I'm going to give you a full report to the human. So please go ahead and talk to the human. So that's the whole thing of that. But now let's come on to Azure Monitor Alert rule. I talked about like the OpenAI stuff. How does it act? but how do you, kind of have the policies? How do you have the alert rules? So for example, I used something called as Microsoft Insights dash schedule query rules, which is my, like, okay, you alert the type, you run a query, and you know fire when the conditions are met. Like for example, I say I expected to it to be integer and 356 characteristics, and you run and alert me when that is not met, and that condition is not met. That's where you can actually have your own rules and kind of have this whole set. And each and everything, all the routes, you have it in something called has the log analytics workspace. So you put all the telemetry, like let's say, oh, I ran this and it did not met at what time, and you summarize like how many did not meet it. That's all, everything is stored in something called has KQL query and analytics workspace, log analytics workspace basically. So that's all good. Like you did not meet the query. What was, like, kind of like, you did how many evaluation, like first type or the second type? How many minutes did it take for you to invoke the whole logic that you did? That's what this whole Azure Monitor or alert rule is. It's just like a rule book. You have a set of rules. Is the conditions met? You run it like multiple times. How many failing periods? Like within 90 seconds, I got this much. What's the actions, like, kind of like, what should I do if the alert is there? You just point out to the logic app saying like, hey, the alert is there, go into the logic app. That's what this whole Azure Monitor alert route does. Now coming to the automation, you you had the PowerShell run invoked by the alert rule. You had the chat GPT diagnosed like it was a drift rule. But how do you have the automation run book? So basically, you need to have something run, right? So for example, in this you see data set, and you have old column and the new column. So you want to change it from the old column name to a new column, right, name. So you have your code dt column renamed, and write delta basically, which is changing your whole, whatever. Let's say you had something called amount USD and it was changed to amount. So it's going to change for the whole pipeline, and it handles any column rename, not just like the specific ones like 12th row or 13th row. Whatever you have, it has amount USD, you're changing it to something called as amount. Basically the whole format is rewritten. So whatever, first thing is whatever was amount USD, right? It is the old column, which is the bad record, is stored in quarantine. Then this whole thing goes there, changes its name, then inserts back into the one, basically the stream of the pipeline. So it just reruns the pipeline. It is the whole closed loop happening. So coming to this part, okay, you have got a new file, but you need to trigger or like scan the data set. Basically, like I've added a new data set, but is it sure it's meeting all the factors? Is it meeting the schemas? Is it meeting all the rules? That's what is called purview scanning client. Basically, you have added a new data set, but you need to make sure that the new data path, the new data set is all good. That's where you use this scan trigger on a new data set. And you're using call as like the scan name. You're scanning what is the event ID. Like each and every event has its own event, so you are doing that. You have your rule book. For example, for mine, I have named it as PI default. So whatever the rules are there, it's going to scan for with the new data. So you have got the whole data, you have scanned it, you have run the whole data. So have your data ready for your any categorized or like a Power BI or SQL. So that's where, like, if something goes wrong, you go there. If something goes right, you come here. So coming to the architecture, I'm gonna be like, I talked everything like from start to end. You would have understand the whole data architecture. You had a data source, where you get the data. Then you have event hubs where it gets like, hey, is now, everything is validating the data. That's what the event hub does. And ADF basically it validates like you have got the bad records, the good records. It sends to the bronze if it has a good records. And I also talked about bronze, silver, gold ingestions of the whole thing. And talked about like it's basically ready for serving. Basically, all the data which is gold is connected to SQL, and you have a clean, guaranteed SLA data. And I already talked about how do you monitor it, diagnose it, and your Azure Open AI book. So that's the end-to-end architecture. And I already talked about control panel. Like, I gave you an example, like how do you make sure, like, kind of monitoring the queries against the log analytics workspace. If something goes wrong and it is watching, like let's say like you have 4 minutes and if something went wrong, you basically say, hey, it failed or something. You get the logs, you assemble the prompt, you call the open AI agent, you update it, roll back to the old pipeline. So that's the plane with the example which I already gave. So when I talked about quarantine, you have a bad record, you're quarantined. So how does it, like, kind of work through, right? I already gave an example. You have the bronze, which has like a raw data saying like, hey, I have passed through the schema data, but I have to go into the silver. I need to validate some of the DBT rules or something. That's you have a fixed quarantine path. If something goes wrong, you just route all this test bad records or all everything into something called as quarantine zone path. And once this quarantine zone path, like, root cause is fixed, you just take everything, check the quality, and make sure that whole data is good, and then audit the trail. Then you're good to go. So, I mean, I already talked about quarantine. It's just like you have a small temporary pouch where you keep the bad records. When it is fixed, you just put it back into the process. Everything is good, but let's talk about network and security architecture, right? So, we have four things, which is the data subnet, control subnet, and governance subnet, and identity subnet. All of these things, data subnet is for the data, basically like how do we ingest it, everything. All those movements should be private, like there should be no logical endpoints. And control subnet is the rules what you're putting for the GPT 40. Like, is this is like, I get this data, you are consuming that data, but I don't want it to be in a public internet or a public seeing what happened, or it should not leave your network boundary. That's what the control subnet do. Governor subnet, it's like it monitors, like scans rules, like whatever the rules are there, it's stored in a very private endpoint, and it just scans like all the things like it's met or not. Identity layer, you all of us knows it's a RABAC permissions to like who has the service. Let's say I am a data senior leader, I would have more permissions to look at the data, and a person who's a data analyst may have like more, kind of permissions, like least per villages per services. So that's the identity layer. And we have NSG rules. Let's say if something goes wrong or something happens, so there's a rules enforce how do you isolate the whole thing. Like if it goes into public or network or something, you need that in defense. So the most whole thing is like it should not go into a public network without diagnostic and remediation payload, basically. So coming into Microsoft previews, what do we talk about there? So already talk like you have a source of ERP system, you get it to an event hub topic, you get it into bronze, and you have like a DBT model. Then you have the gold, basically the whole data ready, and you are just going into the Power BI. So how is that whole done? Auto lineage, we have four capabilities at work, like purviews. So for example, Power BI lineage, it is automatically captured like, hey, I'm ready to write into event hubs into browns. If let's say if on a Power BI can only read a gold table, so purview records that also, like, hey, I just want only the gold record table. and I don't care about what are the rules. So another thing is it has all the policies, sensitivity labels, what's the score, everything is stored in this lineage architecture. We have one lake, that's where we store the whole data, like what of the transaction I did, whatever what was like the from the whole version into new version, what should I like roll back, what's the schema, like the new changes, everything needs a storage. That's what data lake architecture is done. So you have like you can have like a duplicate, like bad records, rollbacks, pipeline, one update, all them we use one lake. That's all. Coming to observability layer, I already talked like when you are first sitting, you need to observe everything, but there are many things which already factor into it. So for example, your memory, your network, your process like rows process, your storage. So that's the infrastructure, right? You're saying like, is your platform healthy, it is good to go. So that's first thing, like you may know like your whole pipeline failed because it was shortage of memory, and it was like it took a lot of duration. That's where it comes infrastructure we are checking out. And second thing is the data quality. Is your test records failed? Is it the per model? Do you like did you expect the number of rows which arrived? Did is like the table good? There is no threshold, there is no duplicate. That's where you check the data quality. Then you are checking for the lineage events. What's the score? What's the confidence score? Was there any new data set discovered? Did it change? Like, let's say you change something, was it affected? That's where lineage events you talk about. KPIs, like how do you is our SL, for example, you always have a GPT or like a AI agent, which does it work? It gives you a confidence level. Is the quarantine number of records waiting for remediation met? Is the what is the refresh of that data, like whatever the changes you had met, what was the decision you made to change, how much time did it take to deliver, is it faster, is it your AI agent getting better? All these layers you talk about the one workspace, one query language. Basically you have alert system, your incident occurs, everything you need to do be diagnosed, it's in a one observability architecture. So coming to governance and patterns and ROI. So I already talked about Microsoft Purview. That is the background of, kind of everything it happens. So when we are talking about there's four things that is like data lineage. So you're coming from an event hub, gone into bronze, gone into silver, then gold as a standard data, then you're going into Power BI. So was there any of this table affected? So Purview answers correctly in seconds. Like you don't need to go back and trace like what really happened. You have like hundreds of the scans which is already done, and what are the dependencies. You just save like almost 7 to 8 hours, and you have like auto discovered, like auto tagged. So it is scanning, right? Basically it classifies like, hey, this is like maybe a minor trigger, it is like a middle version intermediate trigger. So your scanners does it automatically and consistently every time, and it makes sure you have met all the policies, alert rules, violation. That's what is policy enforcement. And you have like what was the data set which happened, like okay, we took out 14 bad data sets and we added it back, which was like which improved by almost 75%, let's say. That gives you the health insights. So you have everything, and it gives you all the tables which is affected, all the tables, uh, or the fresh rate, everything. Basically if once you reach above 200 tables, this is one of the best factor which you can use for governance. Security and compliance, so you have everything all good and everything, right? But you need to make sure your AI agent is running around, like running with two things, which is like it can only read on logs, it can only write access when it is approved to trigger any endpoints. It Any AI agent, you have heard about an AI agent like basically deleting any database or anything, but you should always remember you have given it permissions to do that. When you put on rules for any AI agent, it should not directly touch the data, storage, or compute. It is only recommended after it is having a pre-approved runbooks. And also, like when you're having a runbook approval gates, right? Put a put a basically action teams, like it is dropping a column or a deleting a data set, send a teams message or a send email to on call engineer. Wait for the engineer to give like a approval before executing or anything, so that you don't need the AI agent acting as the main person. And each and every AI, make sure it is logged into your immutable storage, basically one this thing, and audit log, so that what was the reasoning, what was the confidence code, why did you take this action. Make sure everything is auditable and everything is done. And each and every sensitive data which is in quarantine, make sure it has like access control, um, audit notification. Not everyone can read like the quarantine zone. Make sure you have that access rules, basically only these people can read into this. And have like a separate audit notification when you have something sensitive data sitting in your quarantine. And another thing is like um, all the other things. For example, I'm a customer, I'm always saying like my AI agent is going to see my name. So make sure that the AI sees only the error messages and schema drift, not your email address, not your customer or something, or a payment information. So make sure of that. And you're isolated. All this like open AI, logic apps, and everything should be in a VNet private endpoints, so that it doesn't go into the public internet or anywhere. So basically, security and compliance is one of the hard thing in the whole thing. So we all talked about what's the whole key point of that, but what is the real thing which you are thinking about? The quarantine first? No, you don't discard the data. You have a circuit breaker, like if it is something is broken, you just pause it downstream or the upstream. You just break the circuit, isolate the failure, resume it back, and you monitor the whole consumer log and check if that's validating or not, and just put the quality rules and run back the reference. So we talked about observability, what went wrong or anything, right? So there's some pitfalls which may go wrong, which you have to learn from your team. If your like automation is like, it might like a fix of symptom if something goes wrong, uh, but when you're monitoring it first, something may be failing very, very drastically. Always think like this: without observing anything, please don't touch anything. AI agent must diagnose and recommend. Don't give it so much permission. It just like, delete or drop. Governance should be a main concern when it comes like you have like a 300 tables, 400 tables. Always start with observability, go through the policies, and never, never ignore your backlogs or audit logs. Always set up quarantine, talk to the logs, get the the permissions, everything. That's one of the common pitfalls what goes wrong. Three, maturity stage. I think I have talked all of the steps, like observability, what is like everything has a timeline. So make sure you're reactive. uh, every failure pages, like everyone gives, for example, if something fails something, I should get a notification within this hour. So make sure your observability has a time and it is managed. And each quarantine has a rule, monitoring dashboard has a rule, mtr has a time. And your logic app should only work when there is like this top five failures. You can only do that. And autonomous, it should be AI assisted diagnosis, but not a taking like it's like say 5 minutes or 10 minutes. You have a situation where your whole pipeline is broken. Observability AI agent gives you everything, but it's more important is the time is the important. So when we talk about all of this stuff, right, what is it affected? For me personally, if you ask, or any team or a data engineer team, when AI is diagnosing the problem, everything, first thing is the cut down of the number of hours, which is like 4 hours, which you take to kind of like get it fixed, it may be fixed within 20 minutes. And when it is especially in a very critical pipelines, you have like what 10 to 15 engineers you do, or a data analyst, you don't want it. You can have like three engineers around the clock and have like a few people watching the dashboards overnight, and it's more engineers are more focused on building new things, not just fighting fires. And data quality is improved by almost 60%, and with your quarantine policies, dropouts, and everything. So coming to, you heard about my whole thing. So how would you talk, improve yourself? First thing, always talk about like what is the data sources? How do you scan rules? What is the setuping the, you need to learn about setting up the monitor logs, connecting into Fabric, event hubs. Just learn about those whole things, the foundation. Then you can go into second week, or 4 to 2 weeks, which talks about like what are the rules in a SQL models, you can you can code about. What are the contracts, like what are the rules you can write? Is it not null, unique, accepted values? And when you're talking about like alert and response, it takes 2 weeks for you to learn like how do you monitor a rules in a SQL? How do you monitor a rules in Azure? How do you do like a schema evolve? What is the quarantine? What is the pipeline rollback? How do you do like from logic to run back? So I would say within almost, it takes like 7 to 8 weeks just to make sure you're totally ready to learn about the whole roadmap. Always starts with the basics. Learn about the OpenAI, Azure OpenAI Diagnostic Agent, then use the Logic app, but never forget your security and everything. Teams and responsibilities, I think you all know. So basically, has a data platform, you talk about pipeline, you can go into dbt contracts, whatever the existing data functioning rule is. I don't know, much people have not heard about data reliability engineer. That's one of the highest right now role required for anything, which is when you talk about monitoring, automation, run books, which is especially if you're going to automobile, you can go for that. And AI ML engineer are involved in open AI diagnostic agent, prompt engineering. I think most of us are into AI ML modeling. And data governance more lead basically thinks about the scan policies, data standards, what are the rules which have to enact. And that's where the data governance lead is usually into this. And platform architect is security, network, Terraform, your Azure infrastructure. So if you are speaking the whole project, these are the people who are really involved. So if you want to like move into more into reading list or something, you can go into learn microsoft.com. There's a Fabric architecture guide which is really good. And if you are talking about well architecture framework, you can actually look into this website. You can talk about data governance. There's a lot of policy guides into there. So you can go through that. And the uncoding and tooling, I think you need to main focus if you're doing this whole project. Think about Azure OpenAI and Logic apps. You can start from examples, then go into small example from change column to a higher one stream and everything. So I think my whole deck covered few of the code snapshots. If you have anything, please let me know. Yep. Thank you all. If you have any questions, let me know.
Thank you. Thank you.
Yep.
It was a great session and interesting topic you shared with us. And as you know, that the data is very value asset for each company, and we need to make attention. Guys, if you have any question, you can add your question in the comment. If you in the future you see this video, you can connect Kumuda in the LinkedIn or social media to ask your question. Let me check the comments. It seems there is no any question from your side. I think that your presentation, it was so clear, you
Okay.
know. Yeah, but maybe the guys should be review more than one times in the YouTube channel. After that, they had have a question and
Sure.
connect you.
Sure, that sounds good. I took a lot of time, so sorry about that. But yeah, I'm always open to questions and you can reach out to me anytime. Yep.
Sure. Thank you, guys. Thank you, everyone.
Thank
Uh, oh, that's we have a one comment. Let me show you. As a,
you.
it's very interesting for some people.
Okay. Yep. Sure.
Thank you. Have a great day.
Have a great day too. So, bye. Thank you.
Bye bye, guys.